Hi class, today's video is going to be about rational exponents, so it's going to be an extension of the radical section that we've talked about previously. And our goal is going to be mainly to be able to convert between rational exponent form and radical form, and then using our exponents and our radicals to reduce problems as much as possible. I'm going to start off with a basic example here. Here it says we got the square root of 5, and the key thing you need to know is that you can rewrite a radical in exponent form by just using the index and the exponent. So a square root technically has a 2 here, which means we could rewrite the square root of 5 as 5 to the 1/2. So these are equivalent, they're just written in two different ways, the radical form and the exponent form. This also might look something like this. The cube root of x would be the same thing as x to the 1/3. Or the fifth root of 2 would be the same thing as 2 to the 1/5. So notice that the index is going to become the denominator, and any exponent that is with the radicand would be in the numerator. So for example, maybe we had the fifth root of x to the 4th. That would become x to the 4/5. The index goes to the denominator, the exponent goes to the numerator, and then you'd be done. So knowing how to convert back and forth is really important. The basic rule that you could use for this, and I'll write this out in its more general form, this would be what you see in the book, is that the, the y root, so of b to the x is the same as b to the x over y. Or you might also see it written as something like this, all to a power of x. It's the same thing. So this would be b to the y over x. Okay, so that's our general rule that we're going to be using. And so now we're just going to use it to simplify as much as we can. So here's our first example. We have 81 to the negative 1/4. So the first thing you should notice is that our exponent is negative, and if you remember back from our exponent rules, negative exponents have to flip. So it's going to be 1 over 81 to the positive 1/4. Well, we may not know what 81 to the 1/4 is very easily. However, you might be able to recognize it more if you write it as a 4th root. So this is the same as the 4th root of 81. And if you still don't know what the 4th root of 81 is, remember the whole goal is to get our index and exponents to reduce or to cancel. So I could rewrite 81 so that it has an exponent that's a 4. So in this case, 3 to the 4th is the same as an 81. Okay, and now we know that our exponent and our index could cancel out, and that's just going to leave us with 1 over 3. So anytime you can get your exponent and your index to reduce or to cancel, you want to make sure you do that. And that might require you to rewrite your number in exponential form. So I changed the 81 to a 3/4, and then we could reduce. Same thing for number 2 here. We've got 216 to the 2/3. I'm going to go ahead and rewrite this in the radical form. So that would be the 3rd root of 216 squared. Well, looking at that, we may not know what to do with it right away, so the easiest thing we could do is try to get our index and our exponent to cancel. And if you notice that switching it to radical form isn't helpful, then you may have to go back to your exponential form. So see if you can reduce something here, and if you can't, then don't use it. Instead, I could try to get my 216 to have an exponent that's got a factor of 3 in it. So I could rewrite 216 as 6 to the 3rd, all to the 2/3. So notice that these are the same thing, just written two different ways. And now, when we have a power to a power, we can multiply. So I'm going to get 3 times 2/3. The 3's will cancel, and I'm going to be left with 6 squared. And that's going to get us 36. So sometimes the radical form is very helpful. In the bottom it was very helpful, but here in this example it was easiest to leave it in its exponential form. So you're going to have to know how to switch back and forth from forms, because one may be easier than another depending on the information that you're given. The rest of this section is going to be mainly using the concept of the exponential form and the radical form to simplify. So I'm going to try to give you as many examples and variety of examples as I can, and if you have any questions over any of the ones I go through, just make sure you circle them and ask me in class so I can go through them with you. The first two that we're going to go through are just some basic simplifying using some exponent rules, and in this case, for number 3, we have a to the 2 sevenths times a to the 4 sevenths, and all you have to think about in this case is your exponent rule. So remember back when we first learned about our exponent rules, we said that when you're multiplying the same bases, all you have to do is add your exponents. So I'm going to keep the base the same, and I'm going to go ahead and add 2 sevenths plus 4 sevenths. When I add those together, I'm going to get 6 sevenths. So this would be my answer, is a to the 6 sevenths. And of course, if you get something like this, you want to make sure you reduce it if possible, but there's no way of reducing this one, so you would leave it as is. The next example has b to the negative 5/6, and remember we cannot have negative exponents. I'm going to go ahead and change this to 1 over b to the positive 5/6, and then we just have to reduce. Please remember you cannot have radicals left in a denominator, and if you don't see the radical, remember this could also be written as 1 over the 6th root of b to the 5th. And we can't leave that 6th root in the denominator, so we have to multiply the top and bottom by something that can get rid of that 6th root. And remember, the easiest way to do that is to think of what extra number of exponents you need to make 6 go into the exponent evenly. Well, 6 doesn't go into 5, but if we get one more b to make it b to the 6th, then those will cancel. So I'm going to go ahead and multiply the top and the bottom by the 6th root of b to the 1st. And when I do that, I'm going to have on the top the 6th root of b to the 1st over the 6th root of b to the 6th. Because remember, when you're multiplying, you add the exponents. And now I have a 6th root of an exponent with 6, and remember those would cancel. So that's going to cancel out, and that's going to leave us with the 6th root of b to the 1st over b. And then we would be finished with this particular problem. Okay, so flip if you've got negatives, and then make sure you get rid of the radicals in the denominator. And the easiest way to tell if something is a radical or not is if it's a fraction, it's going to have a radical in it. If it's a whole number, then you're fine, you can leave it as is. So you can't have fractions in our exponents in the denominator.